Hi kids, time for exam review. So what I'm going to do here is I'm just going to go through the review document that I posted and give you some specifics on what uh, you might expect on the test coming up this week. So I'll just kind of start at the beginning and go through and just give some examples uh, and some thoughts on what you should be prepared for. So the first thing up is Chapter 4, which dealt with the simplex method of solving linear programming problems. And what I'll have you do is, for example, here's an objective function and some constraints. And what I'll ask you to do is create equations using slack variables and then create an initial simplex tableau. So what we'll have here is this ends up becoming negative 7x1 minus 3x2 plus z equals 0. Here we'll have at our first slack variable s1 to make that an equation, x1 plus x2 plus slack variable 2. Third slack variable to our third equation, and then the last one. So we've got our two variables and two slack variables. And from here we can create our initial tableau. So we'll have, for our initial tableau, we've got x1, x2, s1, s2, s3, s4, z, and then here are equals. And so the first row we've got 2, 3, 1, 0, 0, 0, 0, 25. 1, 1, 0, 1, 0, 0, 50. Third equation, our coefficients like this. And then the last one, our final row, we've got negative 7, negative 3, so there's our initial tableau. Then I might say, okay, where are we going to start? What's going to be our first pivot? And so we'll find the most negative indicator of that last row right here. And then we'll look at the ratios of the equals to the x1 variable. So we've got 15 divided by 1 is 15. 105 divided by 3, which is 35. 50 divided by 1 is 50. 25 divided by 2 is 12.5. So this is our smallest ratio. So we'll begin there. So we'll keep the 2 there and make everything below it zeros and work from there. So we might do that. Give you a final tableau, and you can determine what the solution would be to the problem. So here we've got x1, x3, s1, and s3, and z is our basic variable. So we'll have x1 equals, so here we've got two 110 divided by 2 is 55. X2 equals 0. X3 equals 55. S1 equals 35. S2 equals 0. S3 equals 10, and then Z equals 600 divided by 3. So this would be our final solution based on this tableau. So that's chapter 4. So chapter 5 deals with the financial math formulas and problems. And what I'm going to do is I'm going to give you equations. So I'll give you a continuous compounding equation. Here is shown the compounding interest equation. Give you ordinary annuities and annuities due. And what you'll do is, given a problem, you'll have to figure out what equation to use and how to solve for it. So for example, here we've got rate over number of compounding periods. This is the for compounding. Here's the continuous compounding with the E. Knowing that ordinary annuities, your deposits are occurring at the end of a time period, and for annuity due, you've got payments at the beginning. So here's a problem. I've got an account, it's compounded monthly at 8.2%, and in 5 years I want to accumulate $20,000. What must my initial investment be? So in this problem, we've got the accumulation, don't know P, we know our rate of 8.2%, compounding periods, monthly, compounding periods, and number of years. We solve this. 1 plus 0.082 divided by 12, the 60th, and our principal for that initial investment we're going to make is calculated that way. Okay, so you may be asked to find P, you might be asked to find A, find a rate that will get you from a principal to an accumulation, or you can solve for T, how many years, etc. So be able to figure out which variables you have, which you're solving for, and be able to find how to solve for them. This might end up leading you to need to use E on your calculator. So for example, at 6%, when will you have $20,000? So we've got accumulation equals PERT. So we want $20,000. We start with 5,000, e to the 0.06 t, and so we're solving for t. So we'll start out first by dividing by 5,000 on both sides. And to solve for the variable that's in the exponent, we'll take the natural logarithm on both sides. So ln4 on this side. The right side simply reduces to that exponent, and then dividing by 0.06 on both sides, we got ln4 divided by 0.06. And using our fancy calculator, we get 23.01. So basically, in about 23 years, your $5,000 will have turned into $20,000. So that's chapter 5. But again, basically, I'll give you the equations. You'll just have to figure out which equation to use and which variable you're solving for. So for sets and Venn diagrams in chapter 7, we'll do something like this, for example. So if I said we've got 3 sets: A, students from Walla Walla; B, students taking math; C, students ages 25 and older, I might say something like this. What is A intersection C? And in words, that would be students 25 years or older, and they live and they're from Walla Walla. Okay? That's in words. In a diagram, I might say, okay, here's A, here's C. This space in here is A intersection C. Okay? So I can take this formula, or this expression, I can write it in words based on what the sets are, and I can write it using a diagram. Say, okay, I want students taking math or students from Walla Walla. Take these words and write it as an expression using sets. So this would be, I want students from who are taking math, or, which is union, students from Walla Walla, which is A. Or if I wanted you to draw some diagram, here's A and B, and maybe here's set C. A union B would be this here. Oh, would be this here. Anything in A or in B or in the two of them. Right? And then another thing I might do is say, okay, here is a Venn diagram, and I've got this right there. How could you write that in words or in an expression? Well, this, it looks like these are students from Walla Walla, who are 25 and older, but not taking math. So they are in set A and set C, but not set B. So they're from Walla Walla, they're over 25, and not taking math. And that would be A intersection C and intersection complement of B or not B. So we'll have problems like that. Venn diagrams, and this is what I mean by that. So here's all this information: 60 are in the universe, 25 are in set A, 30 in set B, etc., 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 etc. How many elements in the universe aren't in any of the 3 sets? So what we would do, we've got our universe, which is 60. Here's A, there's B, there's C. So 25 in A, 30 in B, 20 in set C. Obviously 25 and 20 and 30 is 75, which is more than 60, but this suggests that there's overlap, which is what we can see here. So 3 are in all 2, or 2 are in all 3, excuse me. So that means the intersection of all of them has 2 elements. Next, we've got 8 in A and C. So between A and C, that's this area right here. Well, we've already got 2 there. That must mean there are 6 here. So 8 in all are in A and C together. 2 are also in B, 6 are only in A and C. We've got 6 in A and B. So A and B is this area right here. So we already have 2 there, so we need 4 more here. So a total of 6 are in A and B. 2 are also in C, 4 are only in A and B. And then 7 are in B and C. So here's B and C. So that means there's 7 total. So 5 in this space, 2 in that space for 7 total. And then what we can do is say, okay, if A is 25, that's this area, this area, this area, this area. So we have 12 combined here, 13 more make 25. If B equals 30, we have 4 plus 2 plus 5 plus this equals 30. So that gives us 19. So 4 plus 2 plus 5 is 11. 11 plus 19 equals 30. And then down here for C, elements that are only in C, so 6 plus 2 plus 5 plus this must equal 20. And so that's 7. So 7 plus 6 plus 2 plus 5 equals 20. Now, the total in the universe is 60. So anything that doesn't show up in these spaces is on the outside. So this, so 13, 4, 19, 6, 2, 5, 7, plus whatever's out here has to equal 60. So the total here would be, well, right here we've got 25, plus 5, 30, plus 19 is 49, plus 7 is 56. So there must be 4 out here to equal 60. That means the answer to our question is 4. So given information like this over here, can I answer some questions about some Venn diagrams? So that's what I mean on the review document, solving Venn diagrams. And that covers chapter 7. So one of the things we can do here is we can determine the value of this game or values within the game. So if this is player A, 2 strategies, player B and 2 strategies, what's the value of the game if player A chooses strategy 2 and player B chooses strategy 1. Now if the matrix is set up in terms of player A, 2 is a gain. Positive numbers are gains for player A, or player B pays player A, and the negatives are player A pays player B. So if player A chooses strategy 2 and player B chooses strategy 1, the value is -4, which means player A pays 4 units or dollars or whatever it is to player B. Okay? If player A chooses strategy 1 and player B chooses strategy 2, we have, so strategy 1 for A, strategy 2 for B, that's -1, which means player A pays player B 1. Okay. Now, is this a strictly determined game? Is there a optimum strategy for both players to play. Well, we can determine that. We can see if we can find a saddle point. So if we take the minimum in each row and underline it, and then we take the maximum in each column, we would have a saddle point at -1, or where A chooses strategy 1 and B chooses strategy 2. So that would be the best outcome for both players to play. Next, we can look at mixed strategies. So if there's a payoff matrix, there's not an optimum strategy. It's not strictly determined. So in this case, if we take the row minimums and then the column maximums, we don't have a saddle point. So this isn't a strictly determined game. So players A and B will use different strategies. So A will play strategy 1 30% of the time and strategy 2 70% of the time. Player B will choose strategy 1 60% of the time and strategy 2 40% of the time. What would be the expected value of this game? Simply by using matrix multiplication, the expected value of the game will equal A times M times B. And so we'll change B, so we'll have A 0.3, 0.7 times M times B. So we'll have a 1/2 multiplied by a 2/2. That works. The solution will be a 1/2, and that'll be multiplied by a 2/1. That works, and then the solution will be a 1/1 matrix, or just the expected value. So, calculations for the first A times M, we've got 0.3 times -2, which is -0.6, plus 0.7 times 2, which is 1.4. So 1.4 minus 0.6 is 0.8. And then first row times second column is 0.3 times 4, which is 1.2, and 0.7 times 1, which is 0.7. So 0.7 plus 1.2 is 1.9. And we'll multiply that by 0.6, 0.4. So we get 0.8 times 0.6, which is 0.48. And 1.9 times 0.4, which is 0.76. So the expected value of this game would be 1.24. So considering this game is played many, many times, the expected outcome for each game would be a payout of 1.24 to player A. And the last thing we could do is look at what would be the optimum strategies for player A and player B based on this non-strictly determined game. What would be their, what percentage of the time would they choose strategy A, what percent would they choose strategy B? And this involves player A and player B. So the elements of the matrix are labeled in this way. We find D, which is this sum, and then player A's strategy 1 probability will be determined by this. Player A's strategy 2 probability, player B's strategy 1 probability, player B's strategy 2 probability, and then the value of the game is determined here. So it's just kind of plugging and chugging some values. So for D we get M11, which is -2, minus M21, which is 2, minus M12, which is 4, plus M22, which is 1. So that value is -7. And so P1 is, so some simple calculations just give us M22 minus M21 over D M11 minus M12 over D M22 minus M12 over D and M11 minus M21 over D. And so here we've found the strategies for player A. So player A will choose strategy 1 1/7, 1 out of 7 times, and strategy 2 6/7 of the time, and player B strategy will be to play strategy 1 3/7 of the time, and strategy 2 4/7 of the time. And then the value of the game will be M1 times M22 minus M21 times M12 over D, which is -2 minus 8 over -7, which is 10/7. So this is not a fair game since the expected value of the game is not 0, and so this game favors player A. They will win 10/7 of a unit or 10/7 of a dollar or whatever the units for the payoff matrix are. So these little formulas might be handy for your note card. I don't know. Another way to determine the optimum strategies for this payoff matrix would be to use game theory, solving using the graphical method, and there is a little video that covers those problems that are in the Exam2Review module. All right, and there you have it. There's your review for Exam 2. If you got any questions, let me know. If you want to do an online session, let me know. Otherwise, ask questions if you have them, and do well.